Okay, so 1 is less than or equal to z minus 2 plus I is less than or equal to 2. So basically z minus z1 equals r. That's a circle, centre z1, and the radius will equal r. Okay, so if you first of all get the z into 2 minus I, then the centre would be 2 minus 1, and the radius, the distance that z is from that point, is greater than or equal to 1, but it's less than or equal to 2. So it will be a circle, centre 2 minus 1, which is there. Let's go up here. 2 minus 1, which is there, and radius between 1 and 2. Okay. Alright, now the next one. You can also, with this one here, you can probably also see that if z equals x plus iy, then that means that x plus iy minus 2 plus I is in between 1 and 2. So that means x minus 2 plus I, y plus 1 is in between 1 and 2. So that means that's in between the square root of x minus 2 squared plus y plus 1 squared, 2. So it would be 1 is less than or equal to x minus 2 squared plus y plus 1 squared is less than or equal to 4. So that's the circle centre 2 minus 1. So radius equals the square root of 4, which is 2. Radius equals the square root of 1, which is 1. So it goes in between. The centre goes in between 1 and 2. Okay, so for the next one, so you've got real z, which is x, is less than 4, plus imaginary z, which is y. So that's y is greater than x minus 4. So x minus 4, y equals x. Y equals x minus 4 goes down like that, and it's a straight line. There's no restrictions on this at all. I can't see any restrictions on anything there. Mod z is greater than or equal to 1. That would be a circle, centre 0, because mod z means the distance from 0 is always equal to 1. And you wanted to use greater than that. So that's on the outside here. And then, let's just get that going. Alright. And arg z is in between 0 and pi on 3. So 0 is there, you need an open circle there, and pi on 3 there. That's pi on 3. So the area where it is just there. So it'll be like this. There's 0, go like that, open circle. So where do these two things happen together simultaneously will be just there. That's 1, minus 1, 1. And minus 1, and that angle in there is pi on 3. Okay, if we look at the next one, that there is the distance that z is minus 1 to 1. That distance there is its equal distance. I put 1 there. Okay? So z will move, so it's always equal distance from both of those points. So it ends up being the perpendicular bisector. So the perpendicular bisector of minus 1 and 1 is this line here, which is the y-axis, or x equals 0. There's no restrictions there.